Hi everyone, in this video I'm just going to run through the basics of component vectors. Component vectors are one of the ways that we can work with vectors to add them together. To get started, I just want to talk about what a component vector is. I think what you should know is that every vector has what we call has two component vectors. So let me type this on the screen. Every vector has two components. And that's kind of small, so let me just make that a little bit bigger for you here. Size 24, no, 36. There you go. So every vector has two components, and those components are an x component and a y component. So every vector has an x component and a y component. So if I look at this vector down here, we'll call it vector A. Vector A kind of goes up and to the right. So if I'm looking, it goes up and to the right or northeast. It has an east component and a north component. And the way I draw in its first component, which is usually the x component, is I start at the tail and I extend that x component out all the way. And I know when to stop when I've reached as far east or as far in the x direction as the actual vector is gone. And I label this AX. The y component, if it adds to the x component, just points up as high as vector A goes, and I call that AY. When I put the two components tip to tail, the original vector is the resultant. Some vectors, even though they have two components, one component might be equal to 0. For instance, this vector right here, bx is equal to 0. This vector is all in the y direction. It's only going north. It only has a y component. The x component has a value of 0. If I take a look at something like this vector, which we'll call c, cy is going to equal 0. Another useful thing about components is that, or one of the things that we should keep in mind, I should say, when we're doing components, is that they have a direction. Sometimes the direction may be negative. It's in the opposite direction. If I'm saying that east is positive, which is to the right on the screen, if a vector points to the left, like in this case I'll label this vector d, dx is actually a negative value, and I can count. It's about 1, 2, 3. It's about 4, so it's about negative 4. Here's another one more example of a negative y vector. If I put this up somewhere, here we go. We'll call this vector e, and ey equals, let's see, 1, 2, 3, 4, 5, 6, 7, 8. So it would be negative 8. And since direction is part of a vector, the direction is pretty important when we add them together. So if you're able to get how large the x component is and how large the y component is, that's very useful for adding vectors together. If we have two vectors like what I have over here, I have a red and a green vector, adding them tip to tail would involve a pretty, I guess you would say, oops, the wrong button. A triangle that is not that easy to work with. I mean, this would be the result. And you'd have to use the law of cosines and the law of sines. But with components, what we can do is if I draw in the components for, let's say, A, the components look like this. So we'll call the red one A. This is AX and AY. And then I have BX and BY. If I were to find those components, which I can count, let me see, AX is 1, 2, 3, 4, 5. AY is 2. BX is 1. BY is 1, 2, 3, 4, 5, 6. I can take those components and use those to create the legs of a triangle. So if I redraw, maybe starting here, I'm going to reorder these any way I want, a way that's convenient for me. So I'm going to put all my x's together. So I'm going to make AX first, 1, 2, 3, 4, 5 in length, and then I'm going to make BX. So essentially the components replace the original vectors, and then I rearrange the components any way I want to make the problem work really easily for me. So there's B, there's AY, and here comes BY. 1, 2, 3, 4, 5, 6. And instead of having a complicated triangle, I have a very simple right triangle with sides. Let's say this side would be 5 plus 1, so that side 6, and this side would be 2 and 6, so that would be 8. So I get 6 and 8, and it turns out that this side is 10, and we can figure out the angle. And you can do this with 3, 4, 5 vectors as we go, and add vectors together by finding their components. It takes a little bit more work at the start, but in the end it's much easier because you're only working with right triangles. So I hope that that helps a little bit as a brief introduction to component vectors, and I'll have another video on solving some more difficult mathematical problems with components, so you can look for that.